Please welcome Pierluigi Freni, LIFTT.
Hello, I'm Pierluigi. I'm from LIFTT. LIFTT is an Italian venture capital focusing on early stage deep tech companies and technology transfer as well. My professional mission is to support the company we invest into and work side by side with our founders on almost a daily basis. Investing in deep tech companies, we see a lot of great innovation from all over the world. We have already invested in almost 50 companies in the last 3 years. And when we met the team at the company Specto Photonics, it was quite an easy choice for us because this company embodies our investment thesis. And in particular, I mean, the excellence, the scientific excellence of the team together with the many scenarios that are enabled by their technology and its potential impacts were, amazed us. So this is why we nominated this startup, and we believe that it has all it takes to become the science breakthrough of this year. Thank you.
Breaking the wall to Mechanobiology, Giuseppe Antonacci, Specto Photonics.
So what you see here is a three-dimensional image of a healthy cell. So what you really see is the light being reflected from the volume of this cell. If you compare now this image with the one acquired with a diseased cell, in this case affected by amyotrophic lateral sclerosis, I believe that you will never see any significant differences. So to study the biophysical process that triggers such disease and to truly differentiate these two cells, we then really need to gain additional information. An ideal solution would be to measure the so-called mechanical properties, like stiffness and viscosity, of this subcellular compartment and structure of these two cells. The measurement of mechanical properties can have a profound impact in fields such as life science research, medical diagnostics, and drug discovery. However, the standard electrography methods that can actually measure these properties are either based on a contact mechanism to the cell, so which they are really destructive, limited to the surface of the cell, and low resolution, or by optical technology that rely on physical components that makes this device really complex to use, bulky, and expensive. Specto Photonics has the big ambition of breaking the walls of mechanobiology by introducing the first worldwide on-chip brilliance spectrometer. So integrating all the optical function inside this ultra-compact photonics chip, we can actually create a device that is much more simple to use for non-expert users, non-invasive and three-dimensional thanks to the optical domain, as well as ultra-compact and cost-effective. We believe that all these advantages can truly remove the barrier in the adoption of brilliance spectroscopy in the life science and the medical diagnostics, so that we can truly generate a unique image contrast so that you can now really differentiate the healthy from the diseased sample. Our entry market is the research, where we already have a strong need for such a device. This market will also be used to validate our technology to then scale up toward bigger markets such as the one of optical microscopy and medical diagnostics, along with the continuous progress in our R&D. Advancing our technology together with a continuous expansion in our IP portfolio will be especially important to keep a competitive positioning with respect to the existing players in terms of robustness, ease of use, and affordability, but also to stay always one step ahead with respect to the new players that are actually emerging and entering the field of mechanobiology. Our next step is the optimization of the chip design in order to have a functional demonstrator by the end of 2024. In parallel, we will close a new investment round that will be needed to start the commercialization at the beginning of 2025 and then enter the market by the end of the same year. To reach this important milestone, we do have a very strong team composed of globally recognized experts in spectroscopy, as well as highly recognized people with strong expertise in business development and marketing. Specto revolutionized the way we can measure mechanical properties with a fully integrated technology that has been already validated, 3 patents already filed, and 8 letters of intent already signed. This strong purchase interest has been confirmed by the many academics, researchers, PIs, and clinicians that we have interviewed over the last few years, all really confirming the strong need of such non-invasive and user-friendly device to unlock the access to the hidden biomechanical properties in biology. Last but not least, brilliant spectroscopy has been recognized as one of the top 10 science stories by The Guardian last year. Now Specto makes a big step forward, making this groundbreaking technology really accessible to everyone. Thank you.
You are fast in this block. You're always a 30 seconds advance. We will start with Stefan for the first question. I see you at the back. I look at the jury. Yes, please.
Can you talk a little bit about the architecture of your chip? Because it's a quite complex technology, and the interpretation of it is also not so easy.
Sure. The architecture is composed, so the chip itself is a silicon photonics chip. So it's composed of so-called photonics integrated circuits. What we have is basically 2 building blocks. One is to remove all the excess amount of light. So if you shine light onto a sample, what you have is that 10 to the minus 8 photons is the one that you really want to measure. So the first process we have to make is to have a filter to remove all the excess amount of light. The second one is to resolve the tiny frequency shift that we have to measure in order to derive the mechanical information. So for that, we have some specific structures that can have a very high Q factors in order to resolve these little tiny spectral signatures that we want to detect.
Okay, just want to make sure. Yes, you are a jury too, right? So that's good. Okay, good. You can.
It seems that you have. Did you hear me?
Yes.
Okay. It seems that you have a great technology which offers a lot of possibilities for researchers and for diagnostics, maybe. Could you make a projection on the manufacturing cost that will be that would be a big thing I think for the commercialization? The manufacturing costs of your
So one of the great things about our technology is also that all the silicon photonics chip, when we go to high volume, they can also cost a few hundreds of euro per chip. Then the most expensive part is the packaging. So what you have the interface with the optical fibers and detectors. So at the end, we believe that a single unit can cost down to about 5K.
Okay. Okay, and I don't forget you. I think you were even before, but logistically, it's go on.
Is your intention to commercialize diagnostic technologies yourself, or are you enabling that pathway?
We want to enable this path. We are actually the strategy is to sell the spectrometer as a plug-and-play unit that can eventually be compatible with the existing microscope, for example, or eventually also to medical device like also endoscopes, for example.
Okay. Next question, Simon.
So if I understood correctly, essentially you have optical resonators to do your spectroscopy. Do you need to do this for every different thing that you want to measure? Do you need to do a specific, essentially, photonic integrated circuit?
It's a good question. We actually made some specific resonator that can already, let's say, address most of the biological matter, like cells and tissues. Of course, one can also extend this to industrial application, and for that, maybe for harder material, we need to have a specific design that is a little bit different. But for biology, let's say, we're targeting most of the samples.
Mm-hmm. Sorry for the people at the back. We still have a jury question here in the first row, please. Jazz, so please. Thank you.
Can I ask, what does your proof of concept look like? So what cell type, what disease, what industrial partner?
Yes. In 20 seconds, please.
In this case, what we have validated this with, for example, looking at cells that is diseased by amyotrophic lateral sclerosis, but can be many other diseases that where the mechanical property really play a key role. Like, for example, in ophthalmology, you have elasticity in the eye that when there is a disruption, it can cause keratoconus, glaucoma, or other disease. In cancer, you have cells that reduce elasticity in order to go in metastasis,
yes,
and many others that are...
Yes, many other things. Thank you very much.
Thanks a lot.
We are at the end of the time.